Hey, Bhavin, how's it going?
Hey, Michael. Excited to be on another Cloud Native Data Management Day session here. And thank you for kicking us off. I was just logging into my AWS portal. And once that's done, I can share my screen and we can get started.
Sorry, I put you on the spot for a live demo.
So,
But yeah, you're
yeah.
becoming quite a regular, right? In the Cloud Native Data Management Day. I think so we started off again in KubeCon EU 2021. So that was an all virtual affair, and then we pivoted round to KubeCon NA, and then did the virtual or the live stream and in-person event at AWS. And I know you were there for at least two of them, but I expect you were
Yes.
probably there for the first one as well.
Yeah, I
But
was there for the last two ones, so like KubeCon, NA, and then AWS reInvent, and like doing virtual sessions. So this is always fun. Unfortunately, I won't be able to make it to KubeCon EMEA in Valencia, but yeah, other than that, I'm looking forward to participating in the community. I'll be a spectator in that event, I guess.
good stuff. Same here. I won't be there either, but we will be represented, I'm sure. So, Bhavin, without further ado, I'll hand this over. I'll keep an eye out on for any questions, but I'll be back in a bit.
Okay, thanks, Michael.
Cheers.
So, good morning and good afternoon, everyone, and thanks for joining this live stream. Today, we are here to talk about how you can avoid any single point of failures when you're running containerized applications or your containers on your Amazon EKS clusters. And again, as Michael hinted in the introduction, this can apply to any other Kubernetes distribution as well. But today, specifically, we are talking about Amazon EKS and the AWS ecosystem. My name is Bhavin Shah, and I'm a technical marketing manager with the Cloud Native Business Unit at Pure Storage, or the Portworx Business Unit. I've been here for more than a year now, and it's always fun to talk about Kubernetes and Kubernetes storage. The plan for today is I just have one slide before we jump into the demo section. So this will be a demo focused session. But as a backup, since we are doing multiple live demos, I do have a video recorded demo of the whole workflow. So if at any point I run against the quota of the number of load balancers I can provision, which is something I hit yesterday, I'll switch over to the video section, which I recorded yesterday, and then we can like see how to do certain things, maybe not live. So let's hope everything works out. Uh, and this is that one slide. So talking about containers and how you can run them on your EKS clusters, there are a few gotchas or single point of failures that you need to keep track of. The first one is around node failures or availability zone failures, which again are not as frequent, but they do happen. So you need to plan for that as an organization. And to counter against those kinds of failures, you need to have local high availability in your Kubernetes storage or your Kubernetes cluster itself. So your persistent volumes, we'll talk about how in using Portworx, you can have persistent volumes that store replicas across your different nodes in the same EKS cluster. So even if a single node goes down, even if an entire availability zone goes down, Kubernetes will respawn the pod on a different node in your cluster. And because of the storage layer, you will get access to the persistent volume. So there is no data loss. Your application might be offline if you don't have multiple pods for the same application running on your cluster. But as soon as the pod is up and running, your application can continue writing data and serving customer traffic. That's local HA. Next step up is you want to protect against failures or region failures, and this is where you should store backups, right? Not just of your persistent volumes, but all of the different Kubernetes components. And if we look at the previous sessions that we have done, we talk about how backing up containerized applications is different from backing up just virtual machine based applications. So we look at a solution around how you can back up your application, store it in an S3 bucket, store those backup snapshots in an S3 bucket, and then restore them to a secondary cluster as and when needed. And then if you want additional, like if you want to meet those additional SLAs in terms of zero RPO or zero recovery point objective, or really low recovery point objective, and a really low recovery time objective or RTO, that's when you add that next tier or disaster recovery solution. So we look at today, especially, we look at an asynchronous DR solution where we have two EKS clusters. One of them is running in the US East 1 region. Another one is running in the US West 2 region. So you get that geographical availability. So even if your cluster goes down or if your region goes down, US East 1, we all know, is kind of inclined to like fail every once in a while just to keep everybody on their toes. So we'll see how you can activate basically DR migrations and bring your applications back online on the secondary cluster. So as I promised, like that's the only slide. Okay, so 2 slides if we count this demo slide, but let's switch to a terminal session and look at the Kubernetes clusters that we have today. So we have 2 clusters for the demo. We have a site A cluster that's running in US East 1. So if you do a kubectl get nodes, you see we have a 5-node EKS cluster, which is these worker nodes are split across multiple availability zones themselves. And then we have Portworx installed as part of this to provide that block and file Kubernetes storage for your containerized applications. We have different namespaces. So for each tier of the application, there are different levels of data protection strategies that are needed. So again, if you're an organization thinking about data protection for Kubernetes, each you might have to categorize your applications in different tiers and then perform a cost versus availability analysis around how much do you want to invest and to make sure your applications are online. And then you might have some applications that can't suffer any downtime at all, and then some applications that tier 2 applications can take a hit of around like a couple of hours, and then a similar couple of hours for the time to recover. And then tier 3 applications are test dev applications. Even if they are down for a day, or even if they lose a day worth of data, that's not going to be like the end of your organization or end of your business. So once you have those different tiers of applications, you can build data protection solutions or disaster recovery solutions for them. So today we have 3 namespaces defined for each tier. Let's apply our tier 1 application. It's a simple Postgres application, or a Postgres instance with a PG bench load generation tool. So if we apply that against tier 1, and then if we do we deployed the persistent volumes, let's deploy the app itself or the Postgres pod itself. And then while that's happening, let's look at the storage classes that I have, or that my Postgres instance will use as the backend storage. So we have a few storage classes defined because we have installed Portworx. And the default storage class is for something called pxdb. And if we do a describe on that storage class, we'll see that we have like a different IO profile set, which understands how the database is writing data to the storage layer. But then we also have a replication factor defined. So REPL of 3 means that you have 3 copies of the persistent volume stored across your EKS clusters. In this case, 3 copies will be stored across the 5 EKS worker nodes that I have in my EKS cluster. So let's see how our application deployment is going. And okay, so my PG bench or Postgres pod with a PG bench container in it is up and running. If we do a kubectl logs, and then let's just tail it of this particular pod, and then specifically look at the PG bench container, you'll see that I have it set so that it's continuously creating new databases and writing data to the Postgres instance, and it keeps going. So our goal is to make sure that we don't lose any databases and our application isn't down for a long time if a node failure happens. So let's exec into the Postgres pod. And do a tier 1. We'll just open an interactive bash session. So I should know how to type better. Okay, kubectl, like I said. Okay, now we are in the Postgres pod. We can use the pSQL utility. Log in as the PG bench user. Then if we just do a /l, you will see a bunch of databases being created for us. Right now we are at like the 51 or close to 50 databases mark, if you ignore a couple of rows for templates. So that's what our application looks like. Let's exit out of this pod, and then let's exec into one of the Portworx pod to look at the additional details for our persistent volume. So let me just copy the name of a specific portworx pod, and then exec into it as well. At this point, we can use the pixie-cuttle stat utility and then do a volume list. Here it will show you a list of all the different volumes that you have. So our Postgres instance was 50 gigs in size. So let's grab the volume ID for that row. And then if we can just use volume inspect. And here you can see that this volume on the portworx layer has 3 copies. All 3 copies exist, like those 3 exist on these specific nodes. And then it's attached to our Postgres pod, and the Postgres pod is actually running on 173. So 173 is the node which is hosting my pod and one replica of my application. So at this point, let's switch to our AWS console and then just I should have and just try to like simulate a failure. So if we do this, and then so we are looking for the node with, I think the IP address was 55.173, and that's it. So this is running in US East 1B. So and at this point we can have US East 1B go down or the node go down. So that's what we are trying to simulate. So let's just terminate the instance. So it takes a few minutes for the node to completely go offline, and then for EKS to recognize that the node is now offline. So once EKS recognizes that, it looks at all the pods that were running on that node and then spins it up on a different node in the cluster. Because of the way we work with EKS, we'll spin up that, or we'll tell EKS to only spin up the pod on which one of the volume replicas exists, so that as soon as the pod is up, the IO can continue and PG Bench can continue writing and creating new database instances. So let's see. Okay, it's shutting it down. Let's go back to the terminal and then exit out of the portworx pod, and let's do a kubectl get nodes. Here you can see it's already in like a not ready state. And at this point, we can do a simple shell script. So what it does is it deletes our Postgres pod and then spins it up on a different node that's available in the cluster. And just to make sure that we are not stuck in a pending state because of EKS, it's better to just delete it and then spin up a new instance on a new pod. So it has a sleep command. We can look at the script once this is done. But once the new pod comes online, we'll be able to log into it, exec into it, and look at all the databases. And that means that we never had any data loss, and our application was down only for the amount of time that it took EKS to notice that one of the node has been decommissioned or not available, and then spin up a new instance of the pod on a different node in the same EKS cluster. So once all of that is done, this like means that okay, your application is fault tolerant to a node or AZ level failure, and you can still be up and running as soon as your pod is online. So let's do kubectl get pods in tier 1. So we have a new instance of new PG bench pod running on a different node, and if we exec into it, we can use psql login as the PG bench user and do a list. You can see all the different databases that we saw earlier, and much more than that are there. So like we never suffered any data loss or any consistency issues with our Postgres instance. So that is like how you can achieve fault tolerance at the node level. Let's switch to the next scenario, which is where we have a different application running in our tier 2 namespace. So for this particular namespace, we have created an asynchronous disaster recovery solution between our US East 1 cluster and our, let me switch to the second tab. This is the US West 2 region. And we have created a cluster pair object. So if we do a kubectl get cluster pair in the tier 2 namespace, You can see we have a trust relationship created between our source and our destination cluster, or our primary and our secondary cluster. At this point, we also have a schedule policy defined. So this is where you can set policies with that get triggered whenever your migrations are triggered. So if we do a describe, you will see that this policy basically, whenever it's attached to a migration schedule, it copies over your data at a 15-minute interval. Again, this is completely user customizable based on the SLAs that you have for your applications. It will take a daily, it will do a daily a roundup, a monthly and a weekly as well. So you can define these schedule policies to meet your business level objectives or SLAs. And once you have a schedule policy, the next step is to create a migration schedule. So a migration schedule basically defines what should happen. So this is like a recovery plan that you have. So here you can define things like what's the namespace where your application is running, which is the schedule policy that it should use. So the interval at which the application is moved from, or the application is replicated from our primary to our secondary cluster, and a few additional parameters which define which cluster pair object to use, whether I want to include all resources. So this means that whenever we are migrating or copying over our application, it's copying over not just the persistent volumes, but any and all Kubernetes objects and application configuration that you might have on your primary cluster. And then start applications is false, because since this is an async DR, you don't want this to be an active state. So after the first migration, you don't want your application to be also online on the secondary side. So we set that to false. And then in case of a disaster event, we can log on to our secondary cluster and then just activate migrations, hit a simple command, and it will start bringing up the application. So let's apply this migration schedule. Actually, before we apply that, let's look at what the application is actually. So it's a simple web-based application that I think I already have the tab open. So basically, wherever I click, it generates a new entry, a database entry in the backend database, capturing the pixels, the X and Y coordinates for the pixel where the Kubernetes logo is generated, and it updates the number of database records that I have. So this is my application. Now let's apply the migration schedule. And once it's applied, we basically copy over the persistent volumes first. And then once the persistent volume is moved over, we copy the other remaining Kubernetes objects. So we can use a couple of different commands. So we can do a startctl get migration schedule in the tier 2 namespace. And that shows what's the progress. A migration schedule basically creates an individual migration object at every interval. So as you can see, we have our first migration that's active right now. It's copying the volumes. It's in progress. We have one volume that's being copied over. If you want to look at additional details in terms of how many bytes have been transferred as part of this migration object, you can do a kubectl describe on the migrations. And here you can get a full detail around like, okay, what's being migrated. It looks like our migration has been completed successfully. So if you do a startctl get migrations again, you will see that our stage is final, status was successful. It copied over one persistent volume and 7 different Kubernetes objects as part of the migration. Let's go to the secondary cluster in this case. And if you do a kubectl get all in the tier 2 namespace, again, tier 2 namespace did exist, but none of these objects did. So as you can see, 47 seconds ago, these objects were spun up. But one thing to note here is you don't see any Kubernetes pods. Like you see the deployment objects with their replica count set to 0. You see the service objects. If we do a kubectl get PVC, you see the persistent volume already being created. But since we didn't set the start applications flag to true, it was set to false, we don't see any pods. This can be like, let's say a disaster happened, US East 1 went down, or your primary EKS cluster went down. At this point, you can just use one of our commands, startctl activate migrations, and specifically for the tier 2 namespace. And that's when it already had the metadata of how many pods were part of your deployment. So once you activate the migration, it begins and deploys those pods, or basically increments the number of replicas that you had for your deployment objects and spins it up on your secondary cluster. So if you do a kubectl get all in the tier 2 namespace now, you'll see our pods have started to come up. So both of them are already in the running state. So what we can do is we can copy this load balancer endpoint and navigate to our browser. Hopefully, the ELB is up and all the different instances that are backing it are online. So usually it takes a few seconds for ELB to come online. But as you can see, this was our source site, this first tab. This last tab is our destination site. It's running in US West 2. All the 12 database records showed up, all the different Kubernetes logos showed up. So our application was successfully migrated or failed over from our primary to the secondary site. You can easily fail back when your primary cluster is online, and we'll sync the data at the first migration, and then you can do a similar activate migrations on the primary site as well. So that was the second demo. Let's look at the third scenario. And for this, we have another namespace and another application deployed for you. So here you can see we have a simple WordPress app running in the tier 3 namespace. And since this organization only publishes one new blog every day, it can sustain some data loss. It's not a really critical site. So it doesn't need a disaster recovery solution. It can just get by using a data protection solution where like any blog posts that are published, it has an SLA of 24 hours. So you can recover from failures and still not have any data loss in many cases. So it's a simple WordPress site, a cloud native data management, and then we have a blog post that was written as well yesterday. If we go to our PX backup UI, which is what we'll use to perform Kubernetes backup and restore for our application, we already have our AWS accounts added. So you have our AWS account and an S3 backup repository that is used to store your backup snapshots. And if we go to our site A cluster and look at the backups tab, I already have a backup running every hour, which basically protects the WordPress site. And again, you can customize these as part of your schedule policies that you define in PX backup as well. And when you log into PX backup, you can look at, once you select a cluster, you will see all the different namespaces that you have configured. So our application is running in tier 3. We can create an ad hoc backup job. So let's just do a demo backup. You can select a backup location. Since we only have one, you can select that. You can create a one-time backup job, or you can do this on a schedule. So your backup admin or DevOps admin can go ahead and pre-create these schedules for you if you're the application owner. And you can select whether you want an hourly backup, a daily backup, every 4 hours, every 8 hours. And then since I already have an hourly going, I'll just do an ad hoc or right now backup. And then I can also, to make these application consistent, I can also specify pre and post exec rules. Once I hit create, PX backup will talk to your site A cluster and then start backing up not just the persistent volumes. So let's look at all the different resources that we have, right? So we have a couple of deployments, a couple of replica sets, a couple of pods, services. If you do a kubectl get PVC, it also has a couple of persistent volumes as part of the WordPress deployment. So PX backup will talk to the namespace, identify all of these objects, and then protect them and store it in an S3 repository. As you can see, it took a while, a few seconds, since it's a small footprint application, and successfully completed that backup job. So if you do a show details, you can see we have those persistent volumes, deployment objects, service objects, and there was also a MySQL secret as part of the namespace. So all of those were protected, and you can use this UI to monitor how your backup jobs are doing. So you can look at the last 24 hours, and then you can also zoom out and look at the last 30 days. I've only had this instance running for the past 2 days, so that's why you only see 2 days worth of entries. But now that you have an application that's backed up, you can select to, you can choose to restore it. So let's hit restore, and then let's do a restore on the second cluster. Again, for this demo, I'm just using the same cluster and I've already added to it. But using a data protection tool allows you to not have a secondary standby cluster all the time. In case of a disaster, you can spin something up quickly using EKS, CTL, and then just add it to PX backup and perform a restore operation for your application. You can perform custom restore. So you can select the namespace in which you want to restore this specific application. You can select what objects inside the backup job you want to restore. And then just once you have decided or customized all of that, just hit restore, and PX backup will initiate the restore job for your Kubernetes application. So let's go to the secondary cluster and then do a kubectl get all in the tier 3 namespace. Again, like it takes like we follow the same thing where we copy or restore the volume first. So let's do a watch command on this end. So whenever the backup job is completed, those resources will start showing up. So as you can see, we have our deployments, our containers are in creating, our pods are in creating state. We did get lucky, and I didn't hit the ELB quota for the live demo. So it looks like we also have an endpoint going for us. So once the containers are up and running, we can basically navigate to that endpoint using our browser and validate that our WordPress site is back up and running. So let's exit out of the watch command. Let's look at the persistent volumes in tier 3. So you can see we have both of those PVCs that existed on the source site now exist on the destination site as well. And then if I just do a kubectl get all, you can see both of our pods are now in a running state. Let's copy this endpoint and let's hope our ELB is up and running and we can. Okay, so it does take a time. We got lucky with the tier 2 demo. Tier 3, I guess we'll have to wait a while. But I guess while we are waiting for WordPress to come up, let's switch to the site. So today we looked at like 3-4 different parts of the Portworx portfolio. But again, for people that want to learn more about Portworx, can join Portworx webinars. But this is just to show how you can have a solution at your Kubernetes storage layer that can help you build fault tolerance to not just node level, but also cluster level, region availability zone level, or even a cloud level for that matter, and help you move your applications where you want them to be. Again, I won't spend much time on this, but you can find me and find other demos that we have around the whole portfolio. So now if we refresh the page, we see that our WordPress site is back up and running. Our post from yesterday is there. So basically we restored our application from our primary cluster to a brand new secondary cluster. But I guess that's all the demos we had for you today. And Michael, do we have any questions? If not, I can cede my time here.
So I had a question in regards to how many ELBs per region can you actually have?
Oh, it was like a really big number. And I don't know, yesterday when I was testing the workflow, I was like, damn it, this shouldn't happen. So that's why last night I was recording a 30-minute long video just to make sure I have something that I can play for the audience.
Good stuff. And then the second question, again, this is from me. The cluster pair, when you obviously deploying the software into the cluster, is that an API service or an API resource that gets pushed into the Kubernetes cluster?
Yeah, so let me show you the YAML file for it, right? So it's a simple it's a Kubernetes object called cluster pair, and it establishes a trust object between your primary and your secondary cluster. And you basically generate that on your destination site. So you take the cluster token, the IP address for your destination site, and create the specification. But then you apply it against your source cluster. So if you do a stalk cdl get cluster pair, you'll see that we sync at the storage layer and the scheduler level as well. So that's why we are able to copy not just the Kubernetes objects, but also persistent volumes. For synchronous DR, there is a requirement of less than 10 millisecond round trip latency, because that in those sync DR cases, we are basically deploying a stretched Portworx cluster. So you won't see like a storage status. We just sync the schedulers between the two cluster, and storage replication is handled by Portworx under the covers.
Yeah, you still need the laws of physics still remain, right?
Yep.
I think that's the important part for any of us talking about data management, data protection, is that Kubernetes is as another platform. It's the same but different to maybe where you've been protecting workloads from virtual machines and physical. And I don't want to steal too much of Tim and Jeff's thunder in the next session, but it's a purpose-built solution for Kubernetes. Is kind of where Bhavin was going from that point of view. But awesome session. Love a live demo. Glad you were able to do a live demo and didn't have to use a video, Bhavin. Yeah, awesome session. Thank you very much.
Thank you.
I'll just drop things down.